We are looking at 9-4 part 2. We broke 9-4 into two different sections. The first part was operations with functions, and now we are going to continue and do compositions with functions. So you do need to pay attention to what you're being asked to do. The notation for a composition has an open circle. So if you see this open circle, it is not F times G. It's not a typo. It is F composite G of X. So to read this, you would write F of G of X. So let me write this again another way. You would say it's F composite G of X. Okay. That's what it looks like.
So you're just plugging in the function for X.
So on this, we would say F of G of X. Now, you don't have to write it out like this. You could write it as F of G of X. And this is sort of like the compound way. So you could see it written, and it does look like the word fog with a little tiny O, but it's not. F composite G of X is the same as saying F of G of X. But the order matters, okay? So if I say F composite G of X, I do prefer to write it this way because then I'm going to take the function G of X and put it inside the function F. Now, some of them are easy, some of them are more complex. The composition part's not the trouble. The trouble sometimes comes in old math skills and doing our math correctly. So first, we're going to find the compositions. Then we want to talk about the domain of each composition. I'm using function f of x and function g of x. And you can see we're going to do f composite g and then g composite f. It's not times x. It's just saying the function is defined by x. So I'm going to take a second and rewrite this as f of, and then I'm going to put in here g of x. So I'm going to go ahead and compress this. So what am I doing? I am physically taking what g of x is, x over 1 minus x. I'm going to put it in place of that. So I'm going to rewrite, and you don't have to write it this many times, but here's f. And what is the function g of x? It is x over 1 minus x. So normally I would tell you to find f of 2, and you would just plug 2 in there. We are going to take all of this and plug it in for x squared. So here I go. The function f is x squared minus 1. Parentheses are really important, and I'm replacing my x with x over 1 minus x. Now, we need to expand this. So my numerator is going to be x, and what is my denominator going to be? Nope, you cannot distribute a power, so you would have to think about this as the numerator is x squared, and the denominator is 1 minus x quantity squared. So whenever you're doing this, you are squaring the top and squaring the bottom, just like our power properties, but I need to FOIL this. So go ahead, take a second, FOIL it. I'm going to rearrange it to clean it up and put it in standard form, and don't forget we have a minus 1 on the end. So if you need to see it written out, write it out. FOIL it, add like terms. And then I'm going to put it in standard form. And that is my answer. However, we want to write it in function notation. So for your final answer, I'm going to say I did f composite g of x. And that gave me x over x squared minus 2x plus 1 minus 1. Now, I know in chapter 8, we would have said, oh, we need to build a common denominator and add like terms. We're not going to push that here, so we can leave it like this, but we did need to expand that. But you don't have to add these like terms. Oh, it should be squared. I wrote it squared here. I need to put it squared here. Good catch. Thanks, guys. Was that what you were both telling me?
Yeah.
Okay. Yep, I put it over here. I didn't write it down here. Now, what about the domain of this? Well, I have a denominator, don't I? What can't I divide by?
0.
Can't divide by 0. So my denominator came from this over here, didn't it? So my domain is that, well, I'm going to say domain restriction, is that x can't be 1. Because my denominator came from that x minus 1 times x minus 1, and we don't want it to be 0, so x cannot be 1. So that is my domain. Now, we are going to do the same functions, but we are going to do a different composition. So here we go. I'm going to collapse this, and I'm going to rewrite my function as g of f of x. Now, I'm only using the colors to sort of help differentiate. You don't need to use the colors. This means I'm taking the function f of x and plugging it in everywhere there's an x in the function g. So some of you can see that, and once you do, it's sort of like circling this and replacing everything over there with it. And that's what makes it abstract, is you were putting a new function with an x in place of an x. Now, the function f of x is x squared minus 1. And so I'm going to rewrite my function g of x with parentheses. So that's going to be x over 1 minus x. The parentheses are important here. And everywhere there's an x, I'm replacing it with x squared minus 1. Okay, so we need to clean this up. Anything we can do for this? No, you cannot get rid of these because can you take it out of all 3 terms? Okay, so the top, I don't really need the parentheses there. The top is simply x squared minus 1. What do I need? Well, these parentheses are here, so I should be distributing this negative sign, right? Addition of the opposite, and my denominator would end up being negative x squared plus 2. Now, you would double check, could you factor and cancel? This top factors x plus 1, x minus 1, but nothing cancels. Okay, so this is my composition, g of f of x, but I still need a domain. So I'm going to say my domain is my domain restriction. I'm going to say what x can't be. Well, same deal. My denominator can't be 0. Agreed? So any ideas? No, x can be 0 because negative 0 squared is 0 plus 2.
X can't be root 2.
Almost. My whole denominator, there it is. My whole denominator cannot equal 0, so you would subtract 2. Negative x squared can't equal negative 2. Then we divide out the negative, so x squared can't be 2. And then what? Then when you take the square root, we are saying we can never have, and it has to be the plus or minus square root of 2. I think a lot of us would get the plus or minus, or the square root of 2, but we're forgetting anytime you solve using square roots, you should have the positive or the negative. Okay, so I'm going to show a little bit less work this time. I'm not going to rewrite this. I'm going to jump right in, but do what works for you, but you have to follow your math rules. So I am going to collapse this, f of g of x, and then I'm visually taking the function g of x and putting it in here. So the function f of x is 3 times x minus 4. See how I'm rewriting it? And then I'm going to put g of x in there, which is the square root of x plus 2. Okay, there's not too much to do here, but we do want to simplify and clean it up. So distribute your 3, and we get 3 square root of x plus 6 minus 4. Final answer? Yep, and then make sure you write your function as a composition. F of g of x equals 3 square root of x plus 2. Make sure it's clear that that plus 2 is not underneath the root. Next idea, domain or domain restriction. Well, I don't have a denominator, right? But I do have a square root. What can I take the square root of? I can take the square root of what? 1? Yep. Can I take the square root of 0? What's the square root of 0? It's 0. I can do that because it's not in the denominator.
Whatever 3 times root x and get it to return negative 2. That's what the restriction.
Actually, it just has to be greater than or equal to 0. So whenever you have a square root, It's whatever is underneath. What you're going to take the square root of has to be greater than or equal to 0. So x is the only thing underneath there. So my domain, x is greater than or equal to 0. Again, that's why I didn't put domain restriction on this one. I'm telling you what x can be. And the other ones, I told you what x cannot be. So that's why it's a restriction. Okay, let's do the next one. It is G composite f of x. Again, it's important to see that the order does matter. Now I'm going to take the function f of x and put it inside the function g. So here's my function g. It's going to be square root of whatever x is plus 2. And what goes in for x? That 3x minus 4. Okay, there's nothing I can do in this problem. You can't take the square root and separate it under subtraction. So my answer is g of f of x is equal to the square root of 3x minus 4. Be very clear that the plus 2 is on the outside. All right, let's talk about the domain. So x can be 0. Well, actually, it can't be, because 3 times 0 would be 0, and then minus 4 is a problem. So I can't just go in and talk about 0. I need to say whatever is underneath the square root sign has to be greater than or equal to 0. So add 4. 3x is greater than or equal to 4, then what? So my x has to be greater than or equal to 4/3. Okay, why is that true? Because sometimes this just seems a little abstract. If I go in here, and I mean, I could just write it out, but if I go in here and I take this 4/3 and I put it in, 3 times 4/3 is what? Is that better? Yeah. So 3 times 4/3, just ignore that little x there. And then that would be 4. And then what's 4 minus 4? So that's the issue. See, if I do this in minus 4, I get 0. So I can put 4/3 in there, but if I put something in there less than 4/3 or greater than 4/3, like 2. If I put in 3 times 2 minus 4, that's not true. X has to be greater than or equal to 2. Okay, this I can do. I can take the square root of 2. I'm sorry. If I put in 1, let's put in 1. 3 times 1 minus 4 gives me a negative 1. Yep. And so why is it this 4/3? Because that's what creates that 0 under here. And then I have to have everything greater than or equal to that. All right, I kept going backwards on that. All right, flip it over. So go ahead. Given these two functions, write the composition. And I need you to pay attention to your rules. You do not have to write this as a compressed composition, but it does help the brain sometimes because you're seeing that you're starting with g of x and you're putting it in the function f of x. You might not always be asked to do both directions for the composition, so make sure you're paying attention. The function f of x is 2 times x squared minus 5. So I replace the x with parentheses. I'm going to drop the 4x minus 1 in. Now that I've done that, did you do the math right? You cannot square over addition and subtraction. So you should have this written out as 2 times the quantity 4x minus 1 and the quantity 4x minus 1, then minus 5. Now, it's your decision here. You can distribute the 2 first and then FOIL, or you can FOIL and then distribute the 2. It's really what you're comfortable with. I prefer to FOIL first, but notice that I'm keeping my parentheses so I don't lose that too. So this will be 16x squared, and negative 4x and a negative 4x adds up to negative 8x. Negative 1 times negative 1 is a positive 1. Come through, distribute. 32x squared minus 16x plus 2. And don't forget that minus 5. And then I'm going to clean it up. So my composition, f of g of x, is 32x squared minus 16x, then what? Minus 3. What about a domain or a domain restriction? The big things that we're looking for at this level, do I have a denominator? Because denominators can't have 0 there. Do I have any square roots, fourth roots? Okay. I can square and multiply any of these numbers, so my domain is going to be all reals or negative infinity to positive infinity. All right, now let's reverse it. Let's do g of f of x. So the function g is 4 times x minus 1, and that x value, f of x, is going to go in here as 2x squared minus 5. So definitely a little bit less work to do. All I have to do is distribute. I get 8x squared minus 20, and then minus 1. So clean that up. And what is my final composition? And I'm using that function notation. 8x squared minus 21. Not do a good job of that, but there it is. 8x squared minus 21. Okay, now what's different about this next one is we have an exponential function. So look, it's 2 to the x. Up domain of that one, you're good. Good thing you guys are here. All right, so you tell me, is there anything that limits us? No denominator, no roots, no, so we are set. It is going to be negative infinity to positive infinity. All right, I was just so excited about this problem. So here we go. What's different? It's not x. So first things first, yes, there's an exponential function, but it's not x this time. So you are basically going to take this and do what you've done for a long time. Take 4, plug it in for x, see what you get out. So I'm going to find out what g of 4 is, and I'm going to replace it with that answer. So if you look at this as g of 4, I'm going to go off to the side. G of 4 equals 7 minus 4. G of 4 is 3. So then the function with 3 in it, I'm going to take that 3. I'm going to plug it into x. And so f of 3 is 2 to the third. And what is my answer? So you could write it f composite g of 4, or you could write f of g of 4, and that equals 8. Okay, now let's see what happens when we do the same functions with the same value, but we reverse the order. This is going to be g of f of 4. So you're basically, if you can go back to elementary school when they taught you about like a function machine, you put something in, you get something out, and then we're putting that back in. So we need to find f of 4. So we will take g of that. Now, f of 4 is 2 to the 4th. Well, what's 2 to the 4th? Yep. Now I'm going to take that 16 and plug it inside the function g. So it would be 7 minus 16, and what do we end up with? You said negative 9? So look, I'm writing it in function notation. I'm saying this was my composition of 4, and I get out positive 9. No, negative 9, right? Negative 9. Okay, so take a second and you try the next two. Pay attention that there is a negative sign there. So we are doing f composite g of negative 3. I'm going to go off to the side and I'm going to take g of negative 3. And I'm going to use parentheses because negative 3 squared is positive 9. Agreed? Then I'm going to take my 9 and I'm going to put it inside the function f. So it would be 2 times 9 minus 3, 18 minus 3, and I get out what? 15. So my final answer, f composite g of negative 3 is 15. So on this one, I'm going to take f of negative 3, or f of negative 3, I'm going to put it in here, and I'm going to do 2 times negative 3 minus 3. So I'm just finding f of negative 3. And that'd be negative 6 minus 3, and I end up with a negative 9. Now, I'm going to take that negative 9, I'm going to plug it in here. So negative 9 squared, and I end up with 81. So I'm going to rewrite that as g of f of negative 3 equals 81. So very important that you pay attention to the order that you're putting it in, your order of operations, and using parentheses.